Hello everyone. Today we will look at how to exploit ECRM to MP3 converter. This is a local buffer overflow vulnerability, and the app can be downloaded from here. So I am following the tutorial by Corelan Cybersecurity Research, and it's just a walk through the tutorial and all the main details. He's amazing. Um, so first thing that we are going to do is, if there is any is there any kind of problem, like we can just crash the system. So this is running on a virtual box, and this is the vulnerable app. I believe there's a vulnerability I have downloaded from the exploit database. So first thing we can do, let's say maybe exploit payload is something like will do a, and let's do use byte object, or you can also say do something like x. Let me start my clock. So we can, this is basically 41. Let's start with say 10,000 A's and we can check it, and our file name mp3u file, and that is the file which can open. We'll say will open file name. We'll write binary flag as f. We can say f dot write or payload, right? And then we'll, for example, we can import OS, and this is running on my virtual box. So we can say os dot system, maybe just copy plus file name plus maybe pbox. That is my shared folder on the virtual box. So everything goes well. So this is import OS. Yes, and we go to XP. So let's see if we can see that thing. So it is here. So it is not, at the moment it is fine. It shows an invalid file. So now let's increase maybe 20,000 A's. We see A definitely, and let's run it, and let's see. So this is our file. Okay, again nothing. So let us make it 30,000 and run. Yes, there is a problem, right? It crashed, the program crashed. So now if you look at, so if the EIP has been, this is our A 4 A's, it has been overwritten and we have a crash. So now, so we have discovered a bug, right? So first thing, so we don't know exactly. So if the point is we won't be able to overwrite this, so we need to figure out what this EIP address is. So we need to be able to find the offset for the EIP. So how do we do? For example, let us do first of all 25,000 A, and we will generate using Metasploit framework. I can create patterns. This is a 5,000 pattern, and so this is our code. I copied that. This is the, so we are using Metasploit to create 5,000 characters pattern, and then I can do it os dot system, this one, and this is our code. So we can take this, paste it here. What we are doing is we are writing this 25,000 A's, and then we, after that we put this, append this pattern. You can create and then copy and paste and combine the things separately, and then and we're moving it into the virtual box again. So okay, So we see this is the pattern. So we wrote a pattern of characters, and so this is what is the pattern which is there. And so now if we can use offset. So SF offset, pattern offset, and this is the 36. So I use, this is a number 3684239. So it's coming to 1109. We have 25,000 A's and lots of characters. So about 1109. 1109. So what we do is, so we go here and we change our pattern. We don't need this anymore. We make it 26109. That many is, and then let us take after that our EIP has to come, right? So let us put binary, and I say B 4 B's, and maybe let us, the last one will create C's, say 5,000 C's. So now, so let us see what happens. So you see we get B, 42 is B, so B, right? And we can see dump ESP is 43. All the ESP, and I'm also going to write down this, the ESP address. ESP is 000F730. So now if you look at the, so we have C. Suppose what we want to do is we want to override this EIP with maybe the address of ESP, and we want to jump and put our shell code here. So whenever EIP comes, it will jump there and it will execute. But we don't know exactly this is the first C that we actually put here, 5,000. So I'm gonna maybe put some, instead of from this C, I'm gonna take maybe few characters in the beginning, something like say A, B, C, D, E, F, G, H, and then I put remaining again C's. B. So I put some and see if correct, if it is actual at the beginning of C, it has to now see that when you dump ESP, we'll see A, B, C, D, right? The 41, 42, 43, etc. So let us see. Yeah, debug. So dump ESP. So what we see, 45, 46. So we see 45. So 41, 42, 43, 44, 45. So we don't see these four. So what we can do, we will put, say, start with X, 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 X. So, and remaining C's. So we have now we sure that these C's directly go to our ESP. So instead of this place, we can actually now put our shell code, for example. So before that, what we want to do is, let us use say now this and try to put some test. So we are going to write this is our ESP, right? So we going to write this with this ESP address. So we have to take the NDNS, the little and big NDN. So we have to write reverse. We type 30 F70 F and 00. So we'll write like X 30 X F7 X 0 F X 00 30 F7 0 F 0. So now this is fine, and this is our thing, and here we are going to put some knobs, 25 knobs, and we put a break, and some more knobs. Okay, so now let us run it again. Debug. See our ESP. Now what you see is a little bit of mess. So this jumping directly into ESP doesn't really work. So we have to find some other way. So but if you look over here, all the modules which has been loaded is here. So we can see this is the RM2 ECRM2 MP3 converter. So we can, for example, use some instruction rather than directly giving the ESP address. We can give some instruction in the module, which is basically a jump ESP instruction. So something like jump ESP. So we use in that code, in the memory, that instruction corresponding opcode FFE4. So if you can find that, and if you use this address here, and so the program will execute a jump ESP, and then it will go here. So we can put our shell code in this place. So let us figure out, we can need to find an address. Where does that, we need to find in memory that address. So we can use the search. So let's search inside this DLL, wherever it is loaded. This is loaded in this, between these two addresses in the memory. So I can search bottom 018F0000 01DBD000 and FFE4 opcode for jump ESP. Let's see. So we see plenty of them. So let us take this guy. So whenever, so if I put that as a EAP, so immediately this is the instruction which executed. So it will jump to this place, and where it will see our shell code or whatever code we put. So I'm gonna write that one is coming to be 01. I don't need, right? 01 AAF2 3A 01 AA. So now again reverse 3A F2 AA 1. Right? Let us do this again and see what happens. So debug. See, this is exactly the the knobs, and we have our break here. See, so it's coming perfect. So now the only thing that we have to check is if you can rewrite this piece here with some shell code. So use Metasploit framework. So we use payload and Windows shell. This is a payload that bind TSP. If you look at the options, we have to set all this. So this is, I have set SEH as the exit function. You can just set, and also we also need to, we'll set the encoder x86 alpha upper. So here this one will create with the uppercase letter, so that in order to avoid bad characters, that's what we are going to set. And then now we'll generate, and output file just call out, and we'll put in Python format, so it's easy to copy it. So I go here and make sure we are in the same directory. So cat out. So this is our shell code. I put it there. So now what we do, we'll keep the first 25 knobs there, and rest we'll just update it over this guy, this buffer. So this is a concatenated byte string, and now all we need to do is we'll just run it. This one. So it's hanging here. So now we'll go to the telnet and check. This is the IP address of the machine, and 444 is a port. Yeah, we got a shell. See, I can look at the directories in whatever command you want to run. So we got a shell. So we hacked into the XP machine. Thank you very much for watching.